good morning time, good evening time, good afternoon time, whatever the case it may be in your part of the world. Crisscrossing wires, and today we're going to discuss, before we get into our battery making videos, and the whole point of my battery making videos will be to attempt to create batteries, next level batteries. And what I mean by that are batteries that can operate at a higher rate of, with more amps, higher current, and be able to do so with minimum sag, and mainly with minimum potential to catch fire, burn up, and melt your bike down. Alright, batteries are very, very expensive. It's the most expensive component of your e-bike. If it's not the most expensive component, then you definitely need to take a look at your battery and possibly upgrade it to a better one, or do what we're going to do here, build your own. Now, like I said, batteries are very expensive. I mean, if you want a high power, high output battery, you're going to spend minimum, and that's not even a high output battery, that's just a decent battery, $2,500. Any of those battery builders that most people are getting their batteries from, those batteries are great batteries. They're rated for a pretty substantial amount of current flow. However, with the new controllers that are coming out or have been out, a lot of those controllers require a lot more amps than even those batteries are designed to handle. So yeah, when you're building batteries, it's not just about what cells you're using and are those cells capable of the amount of discharge power that you're looking for. The battery construction itself has to be capable to handle that amount of current flow. And when we're talking 500-600 amps, I don't think a lot of people realize just how much current flow that is. I mean, that is a lot of current. Now, in bursts, a lot of those packs can pass 500 amps in quick burst, for a couple seconds. But you put a 500 amp load on most of those batteries for any length of time, like a minute or 2 minutes, and I'm going to tell you, some of those batteries are definitely going to fail. And if those batteries don't fail, it will send some of those packs in the thermal runaway, just because the cells are working a lot harder than they should be, because a small P battery, where the cells are putting out their maximum discharge rate for long lengths of time, are going to be subject to thermal runaway. That's something that no one can prevent. The only way you can prevent that possibly is to build a battery that can handle and pass that amount of current, but at the same time not be at its max. So while a 10p pack may be able to pass 500 amps, it's a lot easier on a 20p pack to pass that same 500 amps without stressing those cells out, if you get my point. Excuse me, I got a cold. laying up in this AC all the time, keep runny nose. Anyway, first of all, before you even get started on your battery build, you got to have the at least the decent amount of quality materials to even get started. So I mean, yes, you can build a rudimentary battery quite easily with minimum materials, and it will work. But when we're talking about being safe and you know, not having batteries catch fire and burn apartments down or burn your bike up, you have to, you know, upgrade some things, or at least have them up to spec as they should be. Now, first of all, when it comes to these cells, the reason why 21700s or 18650s are somewhat dangerous sometimes, just how close in proximity the positive is to the negative. Now, although this battery has a plastic casing on it, right underneath of that plastic casing is it's negative around there. So for any reason, if a nickel strip were to heat up, possibly melt this plastic insulation, or a drop, or you know, some pressure causes it to rupture this insulation, that would cause a direct short, and a direct short to one of these high discharge cells would not be a good thing. So first of all, your cells should always have these little fish paper stickers on top of them, the little circle stickers like this, and that just gives them another little extra layer of insulation. It's not foolproof, but it does help. This fish paper being you know, high temperature, it helps for sure, especially when, like I said, that plastic insulation, if you got a lot of current flow going across those nickel strips or copper strips or whatever, can possibly melt that insulation. So first of all, that's one good thing you should have on your batteries. And not only for the top where the, you know, the electrical terminals are, you should also use fish paper in separating. I don't know why my camera died, but anyway, yeah, use some fish paper to help insulate the outside of your pack. You know, wrap your pack in fish paper, as well as this fiberglass insulation. It's hard, it's like a plastic material, but it's actually fiberglass. When you make your little dividers or insulate, you know, 2 packs or 2 sections, you should have this even on the outer shell of your pack, to keep anything from puncturing the pack and possibly shorting out the batteries. So yes, your entire battery should be encased in this fiberglass. Also, obviously, be wrapped in some heat shrink. I'm pretty sure everybody knows that. That'll keep your battery waterproof. Although it will trap heat in, it will keep moisture out. So that's very important, because especially in these welded batteries, moisture can cause corrosion in those welds, which will increase the resistance, which is a reason why initially I didn't like welded batteries, because even though they may perform very well when they're brand new, over time, if they're exposed to air, moisture, these electrodes can oxidize, and when they oxidize, they become highly resistant, and you know, it's going to make a lot of ohms right there. It's going to make it heat up even more, and possibly even break loose. So all types of things can happen when water is introduced into the battery. All right. Next thing you should be doing is when you build your battery and have it all together, before you heat shrink it, it should be wrapped in Cap-on tape. Cap-on is very strong tape that is also heat resistant. I mean, this stuff is strong. I have it in a couple different sizes. That's what you use to keep your pack, hold it, contain it together. Also, some tape like this with the string in it, packing tape. I don't know what this tape is actually called. I forgot for the moment, but it has that string fiber in it. It's very strong, so you'll notice that this is, a lot of batteries are wrapped in this to keep them from falling apart. Now, what you have to remember is that your battery may be fine as long as it's not exposed to any hard shock or impact. But you got to remember, things happen. You may have your pack mounted to your bike in some sort of way where it's not very secure. You know, it's okay as far as you're riding and nothing happens, but let's say you're getting into an accident. Let's say a car hits you. Is your pack going to stay secure when you're hit by a car? Is it going to stay on your bike? When your bike hits the concrete, is your battery going to stay there? Is it going to stay all together? Or is it going to bust all apart? You know, a lot of people glue cells together, which I mean, a lot of people do that. But when they do that, they also encase it in you know, this fiberglass and have it wrapped very securely. But you just got to think about other things that may happen that you may not plan for. And like I said, man, you may hate to see it happen if you get into an accident and your bike hits that ground and your battery becomes detached and starts tumbling down the street. Believe me, all that's going to come apart, and shorts and cells are going to be crushed, and next thing you know, you're going to have a battery fire in the middle of the road and possibly your bike burning up. You know, like I said, it might be fine and dandy as long as you're riding and you cool. Even with bikes that's designed to carry batteries in the frame, you still have to secure the battery. I see people putting batteries in bikes frames like I have, and they just put the battery in there and then put the plastic sides on and think that their battery is secure like that. Yeah, it's secure until you get in an accident, and that battery is going to bust right out of those plastic sides. So inside, I use Velcro like this, and make a whole bunch of Velcro bands to secure my battery to the frame. That plastic siding and those little thumb screw holders and the sockets that's attached into the frame, they're not going to stay there nice and neat when you get into an accident. So you want to secure that thing as best you can. So, you know, get some Velcro. With it, you can buy straps already made. This set here I bought, where it gives you the little links where you can make your own straps. Alright, not only that, a lot of people don't use these holders, cell holders, and the reason for the cell holders is to give your pack more rigidity, as I was just talking about. Instead of gluing them, these cell holders, once you are, you know, they snap together like little Legos. And believe it or not, I know they're plastic, but they will give your battery a lot more stability and rigidity, you know, for impacts. So, you know, nothing is foolproof, but you gotta at least try to make it the best way you can. And obviously you always want to have some really good connectors. Even though I'm not going to be using these are QS8s. Most of the time for these high current packs, these aren't high enough amp reading. You can use several of these and you know, use multiple pieces of wire instead of one solid wire. You know, use a couple like they did here, and that will double the amount of current flow, but make it so you can use two of these instead of one on the end. So, you know, if these are rated at 160 amps, when you're using two of them, that gives you 320 amps. So there's ways to double up on the amount of current flow through one connector. So, you know, using multiple connectors with multiple leads, yeah, you can double up on those amp ratings. All right, so that's just materials. Of course, there's double-sided 3M tape. When you have one or more packs, you know, sticking them together, you, like I said, you just want this pack to be as rigid as possible, so it just will not be falling apart if something abnormal occurs. All right, so that's just in materials. Next thing is your welder. This is a K-weld, which before that I had another welder which wasn't a very good welder, and main reason why I didn't weld in the first place. And I'm also finding that even with this K-welder, there's a lot you have to learn as far as getting a successful good weld, especially if you're attempting to do copper nickel sandwiches, welding through 2 or 3 pieces of material at the same time, especially if the copper is 0.2 and you're using 0.15 nickel or whatever you're using together, combined, the conductivity, all that changes, the resistance. It's a lot more involved than you think. You know, as far as getting a really solid, secure weld that won't be popping loose and that will have minimum low resistance. So yeah, I'm still working on my method and the way I'm going to be doing mine. Like I said, that is something you're going to have to practice on your own to come up with your technique and the way you choose to do it. Like there's several power options for running a K-weld. There's lipos, which I have lipos there. You can make a monocell pack. People use car batteries because to get a really good weld, you need a lot of amps. And most likely, I will probably be using a car battery. Either that or right now I'm upgrading my monocell pack because I had to even reinforce the current handling capabilities of that for the K-weld, because that requires almost 2,000 amps of pulse to get a really good weld. All right, so yeah, you might want to have an amp probe, you know, once you get your battery made, to see how many amps you're actually passing through there. Temperature gun. And one thing I forgot that was really important that I'm going to be putting in my batteries. These are temperature sensors. Now, this is probably one of the most important parts that you could put in your battery. The best way to be safe with your battery and know that you won't be subject to your bike catching on fire or thermal runaway is to constantly be monitoring your battery temps. Now, I have these on my battery, and like I used to tell people, I'm the BMS because I always monitor my battery temperature all the time. Because if you ever see your battery heating up in a way that's abnormal, you might want to stop and take a look, see what's happening, and at least give that battery some time to cool down. So yes, these temperature sensors are a must. If you don't have anything else in your battery, if you want to run a battery with no BMS wide open, you better at least have some temperature sensors on that thing. So although I do run bypass BMS on my discharge side, I do have BMS on the charge side to monitor, you know, my cells and cell temperatures. That is a must. You know, it's the only way you can really be safe with your battery. Let's see, what else. Pretty much that's it. When it comes to wire, I have here one of those 0 gauge wires that I've taken the insulation off, so you can just see how good the copper wire is that's on the inside, because all wires are not the same. Trust me. Some wires claim that they're this and they're that, but they use cheap materials on the inside, and they're just poor quality of wire. And I can show you, I have an example of that right here. I actually have some fairly good 10 gauge stereo wire right here, and I have some very cheap 10 gauge stereo wire right here. Now, I don't know if you'll be able to see this on the camera, but if you look at the inside, both of these wires are claiming to be 10 gauge. Okay, this is the good quality 10 gauge, well, fair quality, and this is some cheap quality 10 gauge. Now, they look the same thickness on the outside, but if you look at that center conductor, you can see just how thick the center conductor is on that one. And look at that. I mean, that's barely 16, 18 gauge, to be honest. If I strip that off, hold on, let's see. Let me get my stripper here. Let me show you this. Check this out. If I can get this off here. Alright. Now, this is supposed to be 10 gauge. Let me make that nice and tight for you. Now, look at that. Do you see the difference? Now, although this is still not premium because it's not copper, but it's still good wire. But obviously copper is always going to be the best. But yeah, look at the thickness in that center conductor. I mean, this is almost double, but yet this company is claiming that this is 10 gauge. Not hardly. So yeah, be real specific on the quality of materials you're using. Same with this nickel. What I've been finding out and learning, you know, you learn as you go. There are a lot of companies selling what's supposed to be pure nickel. That's not pure nickel. It's nickel plated stainless steel. So trust me, the conductivity is not the same. You will not get the same level of welds using pure nickel as opposed to the nickel plated. Sometimes the nickel plated even welds better, to be honest, but as far as the conductivity of it, it's not the same. So you have to make sure you're dealing with a reputable company that's not going to be selling you no fake nickel. There's ways you can test it. They have testers, and you can actually burn the nickel with a torch and flame, and you can look at the color of the flame and, you know, tell whether it's pure nickel or not. So yeah, there's ways you can check that. Pretty much that's it. One more thing I didn't discuss, and a lot of people don't know, when it comes to determining how big of a battery you want to build, as far as amp hour, people don't know how to calculate the amp hour. Well, that's pretty easy. Let's say this mollicell here, this is a P42. This is rated at 4200 milliamps. Okay, so if you wanted to make a 60 amp hour, let me put on my calculator here so my math don't be wrong. 60 amp hour, which is 60,000 milliamps, divided by 4200 milliamps, that will be about a 14p pack. So you would need 14 of these in parallel to make a 60 amp hour. So yes, you're gonna, whatever the milliamp capacity rating is on your cells, you're gonna multiply that. That's your P. How many are in parallel? You know, however many are in series, that gives you your voltage. So 72 volts is a 20S pack. So you have 20 cells in series. But if it's 10P, you have 20 cells in series, 10 in parallel. All together, that's 200 cells. So you need 200 cells to build your pack. So the first thing you need to do also is make sure that your battery compartment where you're putting your battery is, as far as the physical dimensions, is large enough to handle 200 cells. Okay, 200 cells. And you would do that same calculation depending on whatever it is you were trying to achieve. Let's say you wanted a 80 amp hour, 80,000 milliamps divided by 4200. Oops. Hold up. 80,000 divided by 4200 is 19. You know, it rounds off a little bit, but basically 19. That would be a 19p pack. 19 of these in parallel, 20 in series. So 20 times 19, 380 cells. That's how many you need in total. So be sure that you do your cell layout first. Figure out how you're going to situate your cells. And remember what I said as far as putting them in the correct configuration for maximum current flow. That is like this, where that's 1S, 2S, 3S, 4S, and that's 6P, 1, 2, 3, 4, 5, 6 in parallel. Now if you want them, how the current flows through this pack, you want them connected so that the first two rows are connected on the top to put them in series. Then when you flip it over on the bottom, it'll be the opposite two on down the line, and that way you have maximum current flow through that pack instead of putting it in series. You don't want to build your pack in series, you know, that snaking method. You want that current to move evenly all the way down the pack. But we'll get into that you know, when we actually start building the pack. But just in how you do the calculation as far as the milliamp hours and all that, that's what I just told you how to do. So you know, before you even get started, just make sure you got the proper materials. Have some sort of voltmeter, multimeter. I got a cheapie right now. Somebody stole my my fluke that I had. I had a really good fluke meter that was an expensive meter. Unfortunately, I left my truck unlocked one day in somewhere where somebody saw that and got me for all my good meters. So I got to start over and get me some more high quality meters. But for now, you know, it does the job. Let's see what else. Maybe you might want to invest in some sort of Dremel with all the different tips, because when we start cutting our copper and all that, you want to make sure that It's cut to size. You don't have anything overhanging off the cells, which can accidentally short or, puncture or do anything. So, I mean, it's good to have a Dremel. You can, get things pretty precise as far as cutting out and everything. Some type of heat gun. Even if you're going to be doing some you're going to have to do some soldering in your battery. Even if you're not soldering your battery per se, putting on your leads, making some of your bus bars where your leads are connected in your pack. You got to have a good iron. This is a 80-watt Weller, which, as far as power rating, they are higher wattage irons, but this one is a heavy duty one because of the tip that's in it. It's a 10 millimeter solid tip. This tip is very heavy. It holds the heat, which is what you need when you're soldering heavy gauge wires and soldering on copper plates. You need a good iron with a good tip. And actually, I just bought some new tips because even when these tips start getting really bad, corroded from heat over time, they stop transferring the heat as they should. They put some type of resin on these tips that helps the solder flow and the heat transfer from whatever materials you're soldering. And like I said, over time, just from the heat, these tips, they get worn out. And when they do, they stop working as well. So even this iron will start soldering very crappy after a while. So I try to keep some good tips on hand. So yeah, that's pretty much it. Now, I noticed I didn't have a lot of people that were interested in, doing this battery build with me step by step, and that's fine. I will no longer be videotaping everything and putting it on YouTube, especially when it comes to little tips and tricks and stuff that's going to give you an advantage or help your build be a little better than others, because they got plenty of videos on YouTube of how to build regular basic batteries. You can see a million of them all day long. I'm going to be attempting to build some next level packs, and honestly, I feel like I'm to the point where I just don't want to be sharing that really good info with just any and everybody nowadays, because man, people watch your videos, take your information, they go make another video with it, and shoot, they would probably get more views than you get on your own video, and never give you a shout out to, hey, that's where I learned to do this, or I got this secret tip from here, show their sources. So hey, it is what it is. There's a lot of copycatting going on in the e-bike community, and I mean, that's cool, because most of the time we want to share all this info. But when we come to the competitive side of things, I mean, there's a reason why it's competitive. You're attempting to build something better than the next guy. So I mean, hey, that's just how it is. If you go to these drag race circuits and guys are drag racing, they're not going to let other guys in their shop showing them how they do their speed mods and all that. I mean, it just doesn't work like that, especially when you get to a certain level of this stuff. Now, like I said, I'm still learning as I go on a lot of this stuff, and I never claimed to be the best in anything. I've always said the only thing that gave me a leg up is because I had a background in electronics that just helps me learn and understand this stuff a little better than other people. But as far as myself, I still have a whole lot to learn in this e-bike community. But I plan to be one of the best in due time, for sure. So let's say, like I say, I'm going my second year. I say 5 years from now, I'll be a bad man. Make no mistake about it, because I'm going to do what it takes to be just that. You know, I'm going to push myself to do things in the best possible manner that it can be done. Anybody got a problem with that? Too bad, too sad. It is what it is. So, yeah, I'm just reminding y'all, when I start doing this step-by-step thing, I'm going to be learning as I go of the best and the most efficient ways to do it. And I'm going to be sharing that with the people that really want to learn that. And if they really want to learn that, they know where I'm doing that at. Make no mistake about it, it will not be widely available to everyone. So if you're interested, I already told you how you're going to find it. And if ain't nobody there but me, I guess I'll be the only one there. And I'll show y'all the after product. Alright, y'all, but as far as this goes, this is a safety thing. This is basic information that anybody should know. And yeah, I want to share that. So before you even get started, make sure you got the right materials. Alright, y'all, take it easy. Take care. Crisscross and wise. Deuces. I'm out. Peace.